record. All right, so the question is, why do we have to return by reference when we are writing the assignment operator, right? So when we are, let's say, writing A equal to B equal to C. So this is called operator chaining. So typically when we are writing equal, right, it is generally processed from right to left. So you first process B equal to C, and then whatever the value is, you would like to assign it to A. So what would you expect this B equal to C to return? So whatever the value of C needs to be copied into B, correct?
Yeah.
And then you would like to return. So in order for cost to be minimal, you would like to pass by reference the value. Otherwise, a copy constructor overhead would be there. Does it make sense?
Yes. Thank you.
Okay. So probably in the first session, you might have found that you were challenged a bit through both the assignment as well as a lot of new concepts got introduced, which probably looked like a jump from Comp11, I guess. So one of the ways we want to stimulate the learning process is by maintaining a good amount of challenging environment throughout this course. You know, there are two basic ways. There are probably many different ways the learning process can be stimulated. But studies show that two of the most prominent ways for effective learning, this is just a general comment I'm making first. Uh, it's through a Harvard study, as well as they have published a book called Make It Stick. You can even look up that book. So it is explained in that book that in order to make the learning really stick, you need to have two basic methodologies integrated as a part of your learning process. One is what is called active recall, and the second is spaced repetition. So if you can incorporate these two styles in your learning, because life is overall a journey uh, filled with learning opportunities, you will find that with these two techniques, you can actually learn a lot and retain a lot. So generally, active recall is just allowing for um, you to be tested, so that you have to somehow or other think through what did you learn and how I can apply. And spaced repetition is allowing for the typical decay curve of memory to be challenged, where after, let's say, 2 weeks down the line, 3 weeks down the line, you will tend to forget what you have learned. So it's always a good idea to revisit whatever we have learned. And that's why one of the good things about this course is that everything that we are going to do is going to be recorded, and we will also share the recordings as well as the notes if the notes really persist. Last week I had a bad experience for at least the first half. I just would try my best to allow you to at least do this spaced repetition. And then, because the course has been organized in such a way that there will be a lot of challenges thrown at you, so that will require you to do a recall of the concepts that you're learning. So one question that was asked over Piazza was what I can do before I come for the class. So as I have been posting already, more or less a map of how we are going to navigate through the course. The schedule has been already posted. So on these topics, obviously you can um, either, I mean, you can look into the books, you can even look up in the internet on these topics. There are plenty of materials available. But what happens is that when we are learning something in the class, I try to put my own years of experience into dealing with both software as well as the topic of data structures, which is near and dear to my heart. I try to also try to um, bring that topic through that lens. And therefore, no matter whatever you may do, you will always find something new when you are attending these classes. So therefore, it is hard for me to give you something which is going to be directly off the textbook, because there will be a lot of you can say combination of different learning opportunities I have had in my own life. I would like to bring them out as a part of this teaching. So I don't know whether that's a satisfactory answer, but at least like after the class, you will get to refer back to the material. All right. So along the line of active recall, let me ask you a question. So based on what we have discussed last week, what are the different ways we can use the keyword const?
You could use it in function parameters.
Okay. So let's say we can write void foo, we can say const int star, something like this.
Yeah. And then
Okay,
you can't change what the pointer is referencing to.
very
And
good.
you can
I
and
was
you
going
can
to
also
ask the question.
yeah.
So as I mentioned, so we try to refer right to left here. So I personally therefore like to write int const star, because that makes it very obvious. Both are syntactically correct, by the way, because this will basically say pointer to constant int. So therefore it very clearly says that what is constant here, whatever is stored in the box, but this can vary. So so here what you probably meant is that the const can be placed, it can be placed here, it can also be placed here, right? So different ways you can actually put the const down there. Now, if I write something like this, int x, right? And then I write foo to pass in x, right? And suppose the signature of this foo2 is going to be int const reference a. And then I write x equal to 5. Do you think this is going to compile?
Yes, because the const only works on the scope of the function.
Very good. So what we learned overall is that when it goes here, right? And it's almost like here, if I do this, it will be a red zone, right? And then again, here, when it comes out of the function, it's again blue zone. So that's why we said that const is a property not of the type, but of the path. So it applies to the path. All right, very good. So what are the other ways you have learned how to use const?
You can put it after the parentheses, right? The function.
Very good. So would I just put it here like this? Would it have any meaning?
Yeah, I think so. Based on what you told us last time. It just like fixes the output, right? If I'm not mistaken.
Well, if I put a const here, where does the const apply to? Based on the last.
Not fully. I don't remember.
Okay. So you remember that
parameter that you
anybody?
passed.
Yeah, go ahead.
I'm sorry, does it apply to the first parameter that you passed in the function?
Apply to this guy?
Yes, or maybe not, I don't know.
No. Any other thought?
Doesn't it apply to the invisible this that you have with each?
Excellent. Very good. So invisible this pointer can exist when? When is the existence of invisible this pointer comes into play? When this is a member function, right? So this has to be inside a class. When it is inside a class, then this pointer has a validity, right? Right? So then the type of this this pointer is going to be const b ampersand. Not ampersand. So
Wait, could you
correct?
repeat why where the this comes in?
Huh? Say that again.
Could you repeat where the this like pointer comes in to this
Yeah,
again?
so this pointer comes into picture because this has to refer to the current class, correct? If there is no class, there is no validity of this, right? So the context of this is that this is this instance of the class, right? That's what it means actually. This essentially means this instance, right? But how can you have an instance if you don't even have a class? Does that make sense?
So
So it's a non-member. If this is a non-member function, this doesn't make any sense, right? Non-member means when you do not have an enclosing of a class. Is this point clear?
Wait, so just to clarify, so the const, it fixes the pointer to the object?
Let me ask you, did I correctly write or incorrectly write this?
I don't know.
Okay, let's ask yourself this question. Forget about this particular const for the time being. If there is a this pointer, what you would like a programmer to not inadvertently change?
The data members?
Huh? Say that again?
The data members?
Well, we'll come to the data member, but data member, obviously you would like to change sometimes, right? Because if you have a setter function where you write void set member, right? Then you would like whatever value is being passed, let's say int some argument, you would like the member equal to a, right? If you have in the private section int member, right? You can have a function that where you would like to change the member, right? It's not that always I want to protect my member. In some cases, I would like to protect the member, but it's not in all the time. But I'm just asking, when you are giving access to the programmer that one can actually refer through the this pointer, right? One can refer through the this pointer to the mem, right? What you
You
would
don't have
like
to
the
take
programmer not to
argument.
do? What is it that you would not like the programmer to do if they have access to this pointer?
You don't want them to change what
Exactly.
this points to.
Exactly. You don't want them to write this equal to 0x500, for example. That would be totally, that would make the program completely crash itself. Correct? So how can you protect this? By making what const? What would you like to make const then? If you have to protect that one should not be able to modify the pointer itself, right? This is a pointer to the current instance.
Wait, sorry, you said the this pointer, it's implicit, like you don't have to define it? Or sorry, can you repeat that?
Yeah, that this pointer is always there. But inside the function, inside a member function, you can refer to this, right? In your homework assignment, we have referred to this inside some of the functions. And you have seen also this usage of star this, right?
And is that just what it's like currently pointing to? What is like this represent?
When you are instantiating a class, right? So this class B, when I say B, right? And when I call this function b.foo2, right? With some argument. So this pointer refers to this instance of B. That makes sense? So inside the class, I should be able to refer. Now you may create more instances of B, right? They will be different this pointer values. Is that clear?
Yeah, thank you.
Okay, let's come back to here. So what would be the proper definition of this based on the fact that I don't want the programmer to really write something like this equal to this? How would you write the signature in that case?
Would you put in another const for the this possibly? So you
Where would you put the pointer? Left or right side of const?
Oh, the left side.
Very good, because we are reading from, again, right to left, right? You want the pointer to be const, right? So it should be, signature should be something like this, right? B star const this. So it should not be like this. Is that clear?
Wait, so if you pointed to the right side, how would that be different from if you pointed to the left side?
Remember, we are reading from right to left, right? So this is a const pointer to B. So what is constant here? The pointer itself. So therefore you cannot change the this pointer.
Mm-hmm.
But you can change the content because this guy is not const. But the moment you put a const after the function, this const gets applied to this guy. So there is a const that appears here as a result of which. And now you cannot change anything inside the function. Anything in the sense any of the members inside the function. So you cannot write this mem equal to something. I mean, this is of course implicit. You cannot write mem equal to something. Is that clear?
Wait, could you rewrite possibly the exact signature that we're supposed to have like below so it's a bit clearer? Sorry,
Sure.
thank you.
So what I'm saying is that typical signature of this pointer is const this, right? This is the typical signature, right? As soon as I put the const after the function, after the member function, then I also introduce a const here. Now, because of introducing const here, now this is constant pointer to constant b, right? So now what became constant? My members of the current class became, the class itself is now const, right? And therefore I cannot change the members of this class. So whatever is pointed to by this cannot change because of this const. So this is the second usage of, so making the members read only. Okay, I think we have beaten this const to death now. So I think we can move ahead now.
Wait, sorry, one more quick question.
Go ahead.
So this doesn't go, what you just wrote doesn't go in the signature though for the foo2 function, right? That goes somewhere else.
Which doesn't go into the signature? This guy?
So the v star constant this.
No, this is invisible, right? I'm showing what is the effect of putting this const here. Behind the scene, what is happening? I'm just explaining to you so that you will never forget what is the impact of putting a const here and why is it working the way it is working. Okay, I'm just going into the why behind the working part. I mean, I could have just said that, okay, the moment you put const here, every member becomes read only. I'm just showing you why. All right, let's move on.